These two planets are almost the same size, but one is a paradise, and the other is an inferno.
This is Earth versus Venus, two planetary neighbors whose surfaces could hardly be more different.
Earth supports oceans, forests, and billions of people. Venus can destroy spacecraft in only a matter of hours. So how did two rocky worlds born in the same solar system become such extreme opposites? To understand that mystery, we have to begin with something surprisingly similar: their size. Soft transition. Whoosh! Earth is only slightly larger than Venus, which is why Venus is often called Earth's twin. Both are rocky terrestrial planets with metal-rich cores, mantles, and solid crusts. Their masses are also surprisingly close, making their completely different environments even more remarkable. More than 4 billion years ago, both worlds formed from similar material orbiting the young sun. But over immense stretches of time, atmosphere, water, and solar energy sent their climates down different paths. Today, the surface of Earth remains one of the most environmentally diverse places we know. The surface of Venus, however, confronts explorers with heat and pressure on an entirely different scale.
Earth's long-term average surface temperature is roughly 15 degrees Celsius, although local conditions vary enormously.
From frozen polar landscapes to scorching deserts, Earth's climate still permits vast amounts of stable liquid water. On Venus, surface temperatures hover near 467 degrees Celsius and heat us, hot enough to melt lead. That makes Venus the hottest planet in the solar system, even hotter than Mercury. And that sounds strange, because Mercury actually orbits much closer to the Sun. The answer is Venus's extraordinarily powerful greenhouse effect, which traps enormous quantities of thermal energy. Earth has a natural greenhouse effect too, but its atmospheric balance is dramatically less extreme. Venus's dense atmosphere also redistributes heat so efficiently that even its nights remain extraordinarily hot. At sea level on Earth, our atmosphere presses down with what we define as approximately 1 atmosphere. Stand on Venus, and the atmospheric pressure is roughly 93 times greater than Earth's sea level pressure. The crushing force is comparable to being nearly a kilometer beneath Earth's ocean.
Any lander sent there must survive both furnace-like heat and crushing pressure at the same time.
Earth's much thinner atmosphere gives aircraft, ecosystems, and humans a dramatically gentler surface environment. On Venus, the atmosphere is so dense that the surface exists beneath an enormous blanket of gas. Temperature alone would be lethal, but pressure makes the challenge even more severe. Near Earth's surface, the atmosphere is about 78% nitrogen and 21% oxygen. This atmosphere interacts continuously with oceans, rocks, and living organisms through countless chemical cycles.
Venus is radically different. Its atmosphere is overwhelmingly carbon dioxide, with only a few percent nitrogen.
Above the surface lies a global cloud deck containing droplets of sulfuric acid.
These clouds make Venus brilliantly reflective from space while hiding its rocky surface from ordinary visible light cameras. That is why radar became essential for mapping the landscape concealed underneath the clouds.
Earth's atmosphere is comparatively transparent, dynamic, and deeply connected to its global water cycle.
About 71% of Earth's surface is covered by a global ocean of liquid water. Water constantly moves between ocean, atmosphere, ice, rivers, soil, and living organisms.
Modern Venus has no oceans of liquid water waiting beneath its yellow sky.
Scientists continue investigating whether ancient Venus may once have possessed far more water than it does today.
Over planetary history, atmospheric chemistry and solar radiation can profoundly change how much water a world retains.
This difference in surface water may be the single most visually obvious contrast between the two planets. On Earth, liquid water shapes coastlines, transports sediment, regulates climate, and provides habitats for life.
Earth's outer shell is divided into moving tectonic plates that continually reshape the planet.
Venus shows abundant tectonic deformation too, but its global geological system does not operate exactly like Earth's.
Both worlds are volcanic, offering scientists another crucial clue about how rocky planets release internal heat.
Radar mapping revealed vast lava flows and an extraordinary abundance of volcanic landforms across Venus. On Earth, volcanism works alongside oceans, erosion, and plate tectonics to constantly recycle the surface. The result is two rocky landscapes written by very different geological histories. Surprisingly, gravity is one category where Venus feels much more familiar.
Surface gravity on Venus is about 90% of Earth's, so your weight would decrease only modestly.
A person weighing 100 units on Earth would feel roughly 90 units of gravitational weight there.
But when we compare rotation, Venus becomes one of the strangest planets in the solar system. Venus rotates extremely slowly and in the opposite direction from Earth and most other planets. One Venus rotation takes about 243 Earth days, longer than its own year.
Because of this retrograde rotation, the Sun would move across the Venusian sky in the opposite direction.
Earth's weather is powered by sunlight, rotation, oceans, atmospheric circulation, and the constant movement of water.
Venus rotates slowly, yet its upper atmosphere races around the planet far faster than the solid surface.
Scientists call this atmospheric superrotation, and it remains an important subject of planetary research.
On Earth, atmospheric scattering gives us our familiar blue daytime sky.
At Venus's surface, dense clouds and atmosphere create a dim, yellow-orange world with heavily filtered sunlight. Even daylight itself reaches the ground differently, because these atmospheres interact with solar radiation in different ways.
Color, visibility, temperature, and weather all reveal how completely an atmosphere can transform a planet's surface.
Earth's surface supports life almost everywhere scientists look, from deep oceans to high mountains. No life has been confirmed on Venus, and its modern surface is extraordinarily hostile to life as we know it. Interestingly, conditions become less extreme tens of kilometers above the surface, inside parts of the cloud layer. That has made Venus's atmosphere an intriguing target for future measurements and astrobiology research.
But at ground level, the combination of heat, pressure, and chemistry remains devastatingly harsh.
Earth's habitability depends not on one lucky feature, but on many planetary systems working together. Liquid water, atmospheric chemistry, geology, and solar energy all interact over enormous timescales. And that brings us to the biggest question. Why did these near twins become so different?
Venus orbits closer to the Sun, receiving substantially more solar energy than Earth.
Its carbon dioxide-rich atmosphere then traps heat with an efficiency far beyond Earth's present greenhouse effect.
Earth followed another path, with oceans and long-term geological cycles helping regulate its climate.
Small differences early in planetary history can grow into enormous environmental differences over billions of years.
That lesson matters beyond our solar system, as astronomers search for Earth-sized planets around other stars. A planet's size alone cannot tell us whether its surface is an ocean world or a furnace. Venus teaches us that being Earth's twin in size does not mean being Earth's twin in climate.
Earth wins on liquid water, moderate pressure and habitability. Venus dominates in heat, atmospheric density and environmental extremes.
Two similar-sized worlds, separated by millions of kilometers core, and by completely different planetary destinies. And perhaps by understanding Venus, we can understand something even more valuable. What makes Earth so extraordinary?